Good morning, learners, and welcome to KCSE Chemistry Practicals. This is an area that we all know is very important if we are going to do well in our chemistry exam. So what I'll be trying to do here, I'll be trying to take you through to expose you to the techniques that we require to be in a position to handle our practical. So in my first series, I'll be taking you through qualitative analysis. Now, qualitative analysis basically has two, or can be divided into two. We have the inorganic chemistry that basically deals with the analysis of salts. And number two, we have organic qualitative analysis that basically deals with the organic compounds like the alkanes or the saturated hydrocarbons, the alkenes and alkynes, what we normally refer to as unsaturated hydrocarbons, and then we have alkanols and alkanoid acids. But therefore with inorganic here, when we talk about the analysis of salt, basically we are trying to look at the test of anions and cations. Now, as I take you through this here, I'll be able to explain a few, I'll be trying to explain the observations, and more so I want us to really get how we record our inferences, and also how we can make a conclusion from the observations. Now, it's important to mention here that when we talk about observations, we are talking about the things that we can be able to sense, or what we can actually be able to note with our five common senses. We talk about what you see, what you hear, and basically sometimes you may even be required to touch, maybe to explain or to describe a solid. Now, with inferences here, these are deductions that we make from the observations. Now, so follow me here and we look at what we are talking about. Now, the instructions here, you're given solid K, and with this solid K, the first instruction is to dissolve it, or is to add the water. Not dissolve, it's not automatic, but it may be dissolved, but you're supposed to add the water to 8. So let's go. So we have my boiling tube with you here. We have a solid K. So we're going to add the water. We are going to add the water. Now, whenever we add the water, what we need to observe is whether the solid dissolves or otherwise. Chances are it dissolves, or does not dissolve, or it dissolves partially. Now, as you can see here, my solid has dissolved. My solid has actually dissolved. Now, the other instruction here is to divide it into 5 portions. Let's do exactly that. We divide it into 5 portions. We divide it into 5 portions. And there we are. Now, let's have a look at the first. Now, before we get to let's look at the observations. Let's look at the observations. Of course, we've already noted that the solid has dissolved, therefore solid dissolves. That is the first observation. Then it's also important to mention about the color of the solution. Therefore, we're going to mention here solid dissolves, forming a colorless solution. That's what we're talking about. Now, let's go to the inferences. I want us to think about this. Now, when a solid dissolves, what deductions can you make from that solid? It goes without saying that that solid is soluble. Therefore, you're going to have soluble salt present. Soluble salt present. Soluble salt present. Now, again, think about the colorless solution. Think about the colorless solution here. Now, the solution is colorless. What does this one imply? This one implies that the colored ions are absent. Therefore, we can also go ahead here and say colorless solution now. Colored ions absent. Colored ions are absent. Now these particular things here, you have to mention them. And here we have copper ions, which is 2 positive. We have iron 2 positive, and we have iron 3 positive. Now these ones are actually absent. Now copper ions, basically the solution of copper ions are blue. The solution of iron 2 are pale green, and solution of iron 3 ions are yellow. And therefore, when the solution is colored, that means that those ions are actually absent. Now let's move on. We have to the first portion. We're going to add like 2 nitrate followed by nitric acid. So I'm going to have my first portion here, and I'm going to have my lead nitrate with me here, and I'm going to add it there. I want you to observe here, a white precipitate has been formed. You can actually be able to see that. And then I'm going to add nitric acid. That is the instruction. You can see on addition of acid, the solid is not dissolving. Therefore, let's get to our observation. Now, therefore, you're going to have the first thing that you have to observe here is a white precipitate formed. Now, and what you've also seen here, on addition of the acid, the precipitate did not dissolve. Therefore, we can include there, which does not dissolve. On addition of nitric 5 acid. Look at that. That's not dissolve on addition of nitric 5 acid here. So remember here the instructions were 2. It is always important to make sure that whenever you give them 2 instructions, you're going to have 2 observations, because that is what the exam expects. Now the inferences for this. Now in the first particular case here, we have precipitate forming. Now this one here, you realize that lead ions can form a precipitate with carbonate ions, with sulfate ions, with chloride ions. I repeat again, lead ions can form a precipitate with carbonate ions, sulfate ions, and chloride ions. Now, but amongst the four precipitates formed, that of carbonate and sulfide will dissolve on addition of acid. But in this particular case here, the precipitate did not dissolve. That means we can say that sulfate ions and chloride ions are present. Because the precipitates, the lead sulfate and lead chloride here, does not dissolve on addition of acid. But the lead carbonate and the lead sulfate here dissolves on addition of acid. That's what we're talking about. So basically, by now we can be able to tell that that solid K has either sulfate ions or chloride ions. Now let's get to the other procedure. In the other procedure, we are going to add barium nitrate. So I'm going to have my second portion here, and I'm going to add barium nitrate. Work with me again here, and you see what we're talking about. Well, you can all see that a white precipitate again has formed. A white precipitate has actually formed. White precipitate forming. Now, therefore we get there very fast. A white precipitate is formed, a white precipitate is actually formed. Now, if remember already we have seen that we only have sulfate and chloride ions. Now, so addition of barium, what we're trying to do here is that we are adding barium ions. Now think about adding barium ions. Now barium ions can form a precipitate. Barium ions can form a precipitate with the sulfate ions, but cannot form a precipitate with the chloride ions. Therefore, what does that mean? That this one confirms the presence of sulfate ions. So therefore, we can actually say sulfate ions present. That's what we're talking about. Sulfate ions are present. And therefore, we can actually be able to confirm here. We can be able to confirm that my solid decay is a salt of sulfate. It is a salt of sulfate. One of the things that you can actually be able to deduce from here, that actually it is a soluble sulfate. Remember in my first procedure here, I made this conclusion, or my inference was soluble salt present. Soluble salt present. Therefore, I have those two, that I have a sulfate that is soluble. Now, let's move on here. The other one is addition of sodium hydroxide. Now, addition of sodium hydroxide, I'm going to have the other portion. I have my portion with me here. Let me have here, I'm going to have sodium hydroxide. You can see a white precipitate has been formed. Let me put it in excess again here. And the precipitate has actually dissolved. You can see that the precipitate has actually dissolved. Now, we'll get there, Daventry. We get to our observations, and we are going to write exactly that. A white precipitate formed soluble in excess. Now, if you try to go back to the effect of sodium hydroxide as far as cations are concerned, now every time you add sodium hydroxide to a solution and a white precipitate formed, obviously the white precipitates are hydroxides. The white precipitates are hydroxides that are insoluble. Now, this insoluble hydroxides, on addition of sodium hydroxide in excess, if those hydroxides are amphoteric, what happens is that the precipitate dissolves. Now, the question is, which hydroxides are amphoteric? Now, we have the zinc ions, we have aluminum ions, and we have lead ions. Now, listen to this very carefully here. So far, we have seen that we have a sulfate, and the sulfate is soluble. Now, I want you to think about the sulfates of zinc, aluminum, and lead. And here, this is where we must eliminate lead, because lead sulfate is insoluble. Lead sulfate is actually insoluble. And therefore, the fact that our salt was soluble, that means that the lead ions cannot be there. And therefore, what remains after here, we have zinc ions and aluminum ions. Now, in the second procedure here, we have addition of ammonia solution. Let's have it. So you're going to have ammonia solution again with us here. So you're going to have ammonia solution with us. You can see we have a precipitate. We can have a precipitate. Now, one of the things that you have to realize is that the precipitates, you can see the precipitate remains. It does not dissolve even in excess, as we saw in sodium hydroxide. Now, as far as again ammonia solution is concerned, now ammonia solution, object with the effect of ammonia solution on cations. Now, addition of ammonia, and whenever you get a white precipitate which is insoluble in excess, basically the inferences of the cations that can behave that way with ammonia solution, we have the magnesium ions, we have aluminium ions, and we have lead ions. Now, out of the three here, you already realize that we are talking about aluminium ions. Remember, we've already confirmed that we have either zinc ions or aluminium ions, and therefore we are not going to have the magnesium ions, the lead ions. We only have the aluminium ions. Now, let's first of all write our observation. We have white precipitate. We have a white precipitate is formed here, and here you can say which does not dissolve. Which does not dissolve. Does not dissolve. Does not dissolve in excess. That's what we're talking about. And our inference for this one here, we are going to have aluminium ions. Now, if zinc ions was present, what would actually happen here is that the white precipitate would have been formed. Would have been formed because the zinc ions are able to form a complex ion with ammonia solution. Now, in my last instruction given here, I'm going to add sodium hydrogen carbonate. Sodium hydrogen carbonate. Therefore, I'm going to have it with me here. And I'm going to have it. Well, let me add some more here so that you see what we're talking about here. I want you to observe keenly. Get closer. Watch keenly what is happening here. This is what we call effervescence. This is what we call effervescence. That's what we call effervescence. That is what we call effervescence, or what we call fizzing. Fizzing occurs. Fizzing occurs. Every time you are adding hydrogen carbonate, you expect fizzing to occur. And this one has exactly happened. Therefore, fizzing occurs. Now, I've deliberately put this procedure here so that we appreciate something about the aluminium ions. Now, salt solutions of aluminium ions are normally acidic because every time you dissolve aluminium salt, or every time you add water to aluminium salt, they get hydrolyzed. They actually get hydrolyzed. And therefore, this one confirms the aluminium ions. Aluminium ions confirmed here. Aluminium ions confirmed, or we can talk about aluminium ions present. That's what we're talking about. So in my next series, I'll be taking you through organic qualitative analysis. Thank you.